Maximum subarray. Let's do this. Start. I think we talked about, I learned about this, I think I learned about this in a advanced algorithm class at high school. Sorry, college. I wish I learned this in high school. But anyways, it'd be fun to review this question. Okay, without further ado, let's get started. Given an integer array sum nums, find a continuous array. Given an integer array, let's find a continuous subarray containing at least one number which has the largest sum and returns a sum. So we have this -2, blah blah blah, 2. Again, the sum is 6 because 4, 1, -1, 2, 6 has the largest sum, 6. Okay, so I guess we can use the kind of like sliding window technique. So we will start from the first element. Well, if we can assume that the first element will be the max, and first of all we can check the length of the array to see if it only has one. If the size is 1, if the size is 1, we can just return the first array, right? Now, sorry, the first element, right? So if the size is larger than 1, then we can assign the first element to the max, and then we will continue iterating this array. So right now, if we start from the first element, we see -2, right? So max is -2, and we move on to 1. So -2 plus 1 is -1. Yes, the max right now is -1, which is larger than -2, but we could have done better with just 1, right? So since -2 is a negative number, and there is no point of adding this -2, this negative number, when we advance to the next number, right? So I think when we advance to the current number, we should check if the previous sum is a negative number or not. If it's a negative number, then we erase it. We discard it, right? We treat it as 0, and we treat it as 0 being we start from the current index, and then we add this to the current sum. So we'll have a global sum and a current sum. The current sum is keeping track of the sum of your current element, and a global sum is to compare all the maxes that we have got. So without further ado, let's start coding. So first of all, I wonder, no, I'll just assume that the input will be valid, so we'll at least have one element, right? So if nums.length equal to 1, then we'll just return nums 0, right? Because that is at least, well I think it mentioned has a largest sum. If you figure out the end of solution, try coding another solution using divide and conquer, which is more subtle. I think at the algorithm class, I learned about the divide conquer approach, but I already threw it away with my college memories. Alright, let's get started. Okay. So if number's length is equal to 1, then we'll return the first element. If it's not, then we'll make, let's say current sum, and then we have a max, right? So let's call it current sum, which is equal to nums 0, and then what we have here is, I hate this new keyboard. Why is it so dirty here? Okay, so and then we have a max, which is also nums 0. Okay, all right. So now we'll start iterating for n is equal to 2. Now I'm sorry, 1, and then I is less than numbers.length, and then we will do I plus plus, right? Okay, so we'll check if the current sum. Now, first of all, we are at the current element, right? We're at this current element, so we need to check. Okay, if I should add this current element to the current sum or not. The way we check it is by doing current sum. If if current sum is less than 0, well, if it's equal to 0, then we can add it, but it's not necessary. If the question asks us to return the array, then I think that would be unnecessary. But if the current sum is less than 0, then we'll return 0, or else we'll just return current sum, right? Because the current sum, if it's not equal to, if it's at least not a negative number, we'd love to keep accumulating to the sum. Don't forget one thing is that you also need to add numbers. Square bracket I plus this. Okay, so and then you will compare the current sum with the max, right? So max would be math.max, then the current sum compare to max. Okay, and then you advance it, and then at the end we'll return max. Okay, so let's go through this with my algorithm. So we have -1, 1. So say, okay, -2. Right now the current sum is -2. So max is -2, and we're at 1. -2. Current sum is -2, which is less than 0. So it's 1, 0, and we'll add 1, which current sum is 1, and well, 1 compared to -2, obviously 1 is larger, so max updated to 1. And then now, so we're at, so max is 1, and current sum is 1, right? Okay, so now we're at -3. -3 is now, okay, so -3 plus 1 is -2. However, max is still 1, it's larger than -2, so max remains as 1, but current sum becomes -2. Now we have reached 4. Now the current sum right now is -2, which is less than 0, so we add 0 to 4. Okay, we're at this step, in case you're wondering, in case you're kind of lost. And then 4. Okay, so 4. Wait, I kind of lost myself. So current sum is 1, 2, 3, 1, right? Okay. So current sum is 1, but we have 4. So, well, obviously 4 is larger. So current sum max is 4, right? So, current sum and max is equal to 4, right? They're both 4. Now. So now we are at -1. So -1 plus 4 is 3. Not max is still 4. Okay, so and then we see and then we see 3, right? Current sum is 3, and then we plus 2. Current sum is 5. Oh, now it's larger than max, so max gets updated to 5, and then we see plus 1. So plus 1, current sum is 6. Max gets updated to 6. Now we see a -5. Now the current sum becomes 1. Now max remains 6. So I think this will work. Let's get started. Let's test it. This one doesn't make sense. Six. Okay. Oh yeah, it got 0. I was a little bit worried. It doesn't make sense, right? Why would it be 0? Okay. Okay, so don't forget to add parentheses here. First, I forgot. Parentheses. Okay, let's submit it and see if it goes well. Accepted. Okay, perfect. Now it's a pretty easy question. I would love to spend more time to figure out this divide and conquer approach, but for now, I guess this will suffice. Anyways, thanks for watching. We finished it in less than 10 minutes or so. Alright, thanks for watching, and I'll see you next time.